Users who try to automate the repetitive task by writing programs must face the data access challenge. That is, their programming system must obtain access to the data of interest. This challenge is particularly acute for end-user programming because users do most of their work in pre-existing applications like word processors, drawing editors, and spreadsheet programs. By the time they recognize an opportunity to profit from writing a program, their data is often isolated in these applications. How can their programming system, whether it be C, Pascal, or perhaps a macro utility, obtain access to this data of interest? Triggers is a programming system that I'm developing here at the Human-Computer Interaction Lab that explores a novel approach for achieving this data access by utilizing only the pixels on the screen, that is, the colored dots that make up the computer hardware display device. For example, suppose the task is to create text fields and wrap them in rounded rectangles as shown here. To do the task, the user would first create the text field, then select the rounded rectangle tool, send the rounded rectangle to the back, then select the text field, and then group the two objects into one object. The question is, how much of this task can be automated? Obviously, deciding what the contents of the text field should be and its location should be a task for the user. But at this point, one could imagine that the designers of a drawing editor could include a feature to wrap this in the proper sized rounded rectangle. But assuming that this feature is not available, how possible is it for the user to create this automation by writing a simple program? That is, to write a program that selects the rounded rectangle tool, creates it the proper size, and then groups the two objects together. First, let's consider what a C program might look like that would automate this task. Part of the C program might look something like this. Here, a couple statements would set the location of the rounded rectangle to be a certain distance from the text field. And here, the size of the rounded rectangle would be set to be a certain bit larger than the text field. But the question here is, how can the size and location be accessed when it exists only in the drawing application? Triggers is a programming system that can automate our wrapping the text fields with the rounded rectangle task, looking only at the pixels on the screen. Triggers currently contains only two ways of looking at the pixels, which we'll demonstrate now. One of the ways is to look for a rectangular pixel pattern in a particular area of the screen, in a specific location. For example, here we are going to create a trigger that looks at the close box of this window. Here we can see that the newly created trigger detects the presence of the close box of the window as indicated by this check mark. If we close the window, the check mark disappears, and if we reopen the window, the check mark reappears. However, since we're looking in a specific location, if we move the window just a bit, the check mark disappears because this technique of looking at the pixels expects the pattern to be in a specific location. Another more powerful way to access pixel information on the screen is to search a rectangular area for a rectangular pattern. Here we will specify what the rectangular region is, and here we'll specify the pattern to look for. Here we can see that the newly created trigger detects the presence of the closed box as indicated by this check mark. And again, if we remove the window, the check mark disappears. And if the window returns to this position, then the check mark reappears. But unlike the previous trigger, this one searches over an area, so the window can be moved and the closed box is still found. As expected, if we move the closed box beyond the area we told the trigger to search, it no longer finds the closed box. One can easily imagine more powerful ways of searching. However, these two simple techniques will be enough for us to demonstrate how accessing pixels on the screen can give a programming system enough data access to automate meaningful tasks. So now let's show how we can use these pixel accessing techniques to automate the wrapping the button with a rounded rectangle task. First, let's create an example text field. And pop into the triggers programming system. At this point, a desktop blanket has appeared to give clear indication that we are now interacting with the triggers programming system. First, we will specify that we're going to record the conditions that have to hold before we carry out the actions to create the rounded rectangle. At this point, we're working relative to the upper left-hand corner of the screen. We want to be working relative to where the cursor was before we entered into programming mode. So we will double-click on this icon here, and now the line shows clearly that we are working relative to it. We'll set up the first search by specifying what the search region is. And then pointing to an example of the pixel pattern that we want to search for. This M marker has now been moved to the top of the text field bounding box, and we now want to start working relative to it. So we will double click on it, and now the line clearly shows which marker we're working relative to. We'll now find the left edge of the box by searching out in this direction. And we will point to a small piece of the left edge and use this for our pattern. At this point, the M marker effectively marks the upper left-hand corner of the text field. So we want to remember where this location is, so we'll now move this 1 marker down to remember this point. Using the same technique, we will now find the right edge of the bounding box and the bottom of the bounding box. Now we want to start doing the action portion of the trigger, so we will record trigger actions. And we want to select the rounded rectangle tool, which is located relative to the upper left-hand corner of the screen. At this point, we request to do actions and applications. And the desktop blanket is removed, indicating that we can now interact with the drawing application. The next step will be to form the rounded rectangle. But at this point, we want to work relative to the location where the text field was found. So we will go back to programming mode, double-click on the 1 marker, and triple-click on the M marker to indicate that mouse ups will be relative to it. Next, we go back into actions and application mode and complete the actions that will form the rounded rectangle. We'll use a key press to send it to the back. Select the text and group the two together. And this completes our trigger. And now to show that this newly created automation works, we will create another text field. And invoke our automation. And watch triggers automatically wrap the rounded rectangle around the text field and group them into one object. By looking only at the screen pixels, triggers can give enough data access to automate meaningful tasks within existing applications, automation that otherwise might be impossible to achieve. For example, here we have lines being shortened to an arbitrary object in an unmodified copy of McDraw. We can also center the endpoints of lines in arbitrary objects. And still using simple pixel-based techniques, we're able to create automation in text-based applications. In this example, we're finding text in angle brackets and changing it to a bold font. Triggers shows that a significant amount of data access can result using nothing but the pixels on the screen display. Triggers is part of a larger research effort to allow users to weave programming activity into their daily work, a type of programming we call just-in-time programming. Just-in-time programming must address many challenges, including computational generality, risk, ease of invocations, ease of programming, and data access. Of these challenges, Triggers partially solves the data access challenge. In doing this, it enables users to add features to existing applications. Triggers works by taking advantage of the high degree of regularity that exists in modern graphical user interfaces. Not all data access, however, can be accomplished with such simple pixel-based techniques, but when the opportunity presents itself, users should be able to take advantage of this regularity. Triggers shows how the inherent visual nature of pixels and the user's extensive familiarity with the display content can make a programming system that is both powerful and enjoyable to use.